Hi, I'm Stephen Wolf. Welcome to CMR Practically Speaking, where we explain things in 2 minutes, even if they took a lot longer to figure out. Last time, we saw that lowering the Venc boosts velocity SNR, and that aliasing can be unwrapped to push SNR even further. But what does the extra SNR actually buy us? Decades ago, we explored this with simulations. Here are 4 discs of different sizes, each shown at progressively higher SNR. It teaches 2 lessons. First, higher SNR does improve visibility, but with diminishing returns. Past a point, more SNR buys precision you don't need. Second, SNR requirements depend on size. Large objects are easy to detect because we average over many pixels. Tiny objects don't get that benefit. So let's apply this to the adult aorta. The aorta behaves like the large disc. In a typical flow image, a 3 centimeter vessel contains about 100 pixels. Because bright blood imaging gives high magnitude SNR, around 50 to 1, when you run the math, the flow SNR is about 1,000 to 1 when the Venc is set near the peak velocity. Think about that. Even if we raised the Venc tenfold, drastically lowering sensitivity, flow SNR would still be about 100 to 1. That's roughly 1% uncertainty. So what does this mean? Practically speaking, for large vessels like the aorta, we often have an embarrassment of riches. We're typically swimming in SNR. We don't need to chase low Venc to optimize signal. The signal is already more than enough. But is there a downside to setting the Venc too low? Yes. And it can make your flow values less accurate. That's exactly what we'll cover in the last episode. Thanks for watching. See you next time on CMR Practically Speaking.